All right, day 11 of the advent of code. What do we got? Graved, uh, 25 times. Okay, let's see. Uh, okay, okay. Right answer. Uh, oh, four. Oh, I see. 5, 3, 1, 2. Okay. So slow. 75. all these numbers just evolve completely independently, right? Uh, do this. Memory. Okay. That's not good. Uh, the hell. That's really not good that this is so slow. guess these numbers get pretty big. Huh. That big. Huh. How am I supposed to do this? We'll do this. Yes, people have done this. I see. Of course. Being so dumb. I guess the point is that we don't care about the actual numbers. We only care about the parity of the numbers. Uh, oh no, we care. Care about the length. Hmm. Here the length is preserved. Basically like plus 3. See, these lists are just enormous, is a problem. What would go wrong if this just gave you back the length? I guess the answer is nothing, right? Yeah. Wow, that was really bad. Okay. Well, that is that problem solved. So what's going on? So basically, we're given this array, and we're supposed to do this operation on it repeatedly. And the operation operates on every element of the array. So 0 turns into 1. An even number, this is the most complicated rule, turns into like the first half of the number and the second half of the number. So it actually splits into 2 elements. And otherwise, you get the number multiplied by 2024. So the first half is what happens to this array after 25 times. If you do this operation 25 times, how long is the array? And the second half is how long is the array if you do this operation 75 times. so let's get both answers. So part 1 is 25, part 2 is 75. Let's So part 1, 231, 278, and part 2, 274, 22 something, 551. Cool. Okay. So how does the solution work? I wonder if it's still fast if we just do this. Yeah, let's just simplify that a little. Okay, so the point is this like recursive solve function, which we're going to memorize. And this says this answers this question. So I guess one important observation is that like all the elements of the array evolve independently. Like it doesn't, this 125 and 17 are never going to interact. So we could just say, what does the 125 do after 25 steps? And then what does the 17 do after 25 steps? Just put them together. The other observation is that we don't care about the actual list. This is the main thing I spent ages stuck on. We only care about how long the list is. I don't know why I didn't occur to me to do this earlier. Okay, so given that, we can say the length of the list after t steps is just the sum of the lengths of each element after t steps. Fine. And then for each element after t steps, I wonder if you even need to memorize it. I kind of suspect that you do. Yeah, okay. The length of each element after t steps is, if t equals 0, then there's nothing to do. We just get the element back. So that length has 1. Otherwise, we just follow the rules. So if x is 0, then we replace 0 with 1 and do t minus 1 more steps. If x is an even length number, then we grab the left digits and the right digits, and we say, okay, evolve the left digit, t minus 1 times, and the right digit t minus 1 times, and add those together. And otherwise, we evolve x times 2024 t minus 1 times. So for a while, I had a solution like this. This is way too slow because we actually return the list, which is like super long and full of really big numbers, but we only care about the length. Which I guess the point of that is it makes our DP table much smaller, which helps a lot. So I mean, what is the point? Maybe we can like find out how long the DP table is at the end. Yeah, okay. So it's only 120,000 sort of distinct elements. That is distinct pairs of x and t's that end up going through this function. So even though the resulting list is super long, there aren't that many like different numbers in it. And so we can just, we use the fact that if we've seen a 2 before, and we already figured out how long it is after 70 steps, then next time we see a 2 in 70 steps, we can just, reuse that information. We don't need to recalculate it. And that makes it super fast. Just the point of memorization. Okay, so that is all for today. See you tomorrow.